Hey, before the reading week, we talk about the ideas called call by value. I would like to just finish up this topic very quickly. You will see lots of application later. So I just want to give you the principle and some example to just get it straight so we can rely on other future applications. The idea about call by value really is when you're trying to call a method over here, if you look at, let me go back to iPad right away. Okay, so this is some diagram that I went over last time. Okay, so can you see the iPad over here? I don't think it's going to switch, right? Give me one moment. If you don't mind, let me start my iPad again. Sorry about that. Okay. And then I should choose my iPad here. Okay, let's see. Okay, good. Sorry about that. Okay, so this is the general context you want to remember. Okay, just make it general. If you look at that over here, so what we have is we have arguments over here. So this is the actual input value you're trying to pass to your method. Of course, you always got a context object over here. And then if you go back to the method that's being called, let's say m, and they look at how the method is declared. So always you give a type, and I'll talk about type in just one moment. And then we call this parameter, remember? So that's back to our review lecture in the very first few weeks, parameter. Okay, the difference between arguments and parameter hopefully should be clear to you. So now, the tricky thing is, what can be the type for T over here? In Java, you got two different types. One is called primitive. And the other one is called reference type. And the distinction between each one of them is very easy. When you talk about primitive, you can list them all. You got integer, you got Boolean, also you got double, basically all the numerical types, and also you got character. So these are all the primitives. Everything else that refers to an existing class is reference type. Okay? And now the way we handle argument value over here is by simply copy the value of the arguments over here. However, when I say you simply copy the value, so this is kind of interesting. When you say copy the value of arguments, in the case of primitive type being the arguments, let's say if I got integer I, and then it's equal to 10, for example, and then I simply call method m, and then I pass I. In this case, I'm simply making a copy of the value 10, and then try to call that, right? That's easy case. We'll review the example that we did before the reading week very quickly. What's interesting about is the other case. When we talk about reference type, in that case, you have to somehow visualize what's going on over there. That's where the complication comes in, but we'll review that all together today. Okay? It's a very quick brush up for you from before the reading week, but we'll see examples. That's the best way to see the effects. Okay, let me go right away to the example that we left out from last week, but I'll rather just go over the first one again, okay, just very quickly. I want you to consider, basically, you can think about this method over here, where we talk about, we are trying to create a utility class object called U. So this is the context object that we're going to use, right? And then the method that we care for this particular example, can you just focus on this method only? Okay, don't worry about the other two. We'll get there a little bit later. This method here, called assign integer, is very easy. Whatever value you're given as the parameter. So again, j is called the parameter. Okay? And then, so we're going to say whatever value it is, you're going to reassign j to be j plus 1. Okay? Let's see how this method can be called. Okay? I'm going to highlight the line you should really focus on, which is this line over here. Okay? So if you, I'll make it bigger. Okay? The one that's over here. Look at line number 6 over here. We say u.reassign I. Okay? So what you have over here is, you can see we have I over here. Okay, we have I over here, and we have j over here. I is the arguments. J is, on the left-hand side, is the parameter. So we want to know exactly what's going to happen to I and j. That's what we want to know. Okay? A very quick check for you. Okay? Let me just redo the color. Okay? Again, so you got I here, you got j here. If you look at after calling this method here, okay, here's my question. You can see I was initialized to be 10, So that means we have a box called I, the primitive value, which is going to store 10. And then we're simply just going to call this method here. My question for you, immediately after line number 6, will i's value be incremented? The reason I have such suspicion was because you can see when I was passed into this particular method, whatever it is, we're going to increment it by 1. So that's my suspicion. So now here's my question for you. If you try to execute the code on the right-hand side after line number 6, am I going to get I being equal to 10 or 11? 10, okay? For those of you who said 10, that's good, okay? Maybe that's just from last time. But if you haven't got it, that's okay. The most important part for this lecture here is to visualize what's happening here. And then we'll see why it will remain to be 10. Okay, the answer is, quick answer. After line number 6, I remains to be 10. It doesn't change. But let's see why. Okay, what we assume is we already got I being of value 10. When you try to call this particular method over here, what we will do is we're going to switch the context into this particular method over here, right? The only thing you have to know for call by value in order to analyze it is to think about this is my parameter j, okay? And now I'm being passed an argument called I. Always implicitly, there is an assignment, j is assigned to I. So over here, j is the parameter. And I is whatever argument that's being passed by the caller. Okay, guys, I'm going to pause a little bit to make sure you're comfortable with this. So this implicit assignment here is the key to understanding call by value. It doesn't matter whether the argument type is reference type or primitive type. You always have to think of this particular implicit assignments. Okay? Okay, so now, assuming that you're okay with this, how can we visualize this? J is simply just another variable over here of type primitive because j is simply declared to be integer. So now it's going to make a copy of I, which is 10. So now we got 2 separate copies of the value 10. And then if you try to say j is assigned to j plus 1, what we are changing really is just this particular box to be 11, whereas the original one over here simply remained to be 10. That is why after line number 6, if you say assert true, I remain to be 10, it will be okay. You'll be passing. So that's the case for call by value when you have primitive type arguments. Any questions? We're going to apply the same principle in a different case where the argument is reference type, but it'll be very similar. You just have to be careful how to visualize it. Guys, any questions? We okay? Okay, it's more like a wake-up, illustration after the reading week. Let's now consider 2 cases for call by value where the argument is actually a reference type. Okay, the principle is easy. The implicit assignment that we just talked about over here is going to be the same. However, since we know every reference variable stores not the object contents, but the address of the objects. So that's where the things can be a little bit different, the behavior. Okay, let's have a look. So now we're going to have a focus on a different method over here. Okay, I'm going to go over the method with you together, and then we'll see how we can test it. I want you to focus on this method only for this illustration. Okay, and then it's called reassign the reference, reassign. Okay, and then again, you can see Q here is the param. I'll just say P for param. It is of type points, assuming that we have a class called points. So that means Q is not going to store the x and y of a point. It's going to store the address of some point objects. Okay, let's make it clear. And then what we have over here is simply 2 lines. The first line, we're simply going to create a new point, like a new object. Its address is going to be stored into NP, new points. And then the second line, we're simply saying Q, rather than pointing to where it is pointing to right now, it is now going to be reassigned to NP. That's the intention. Okay? It's a little bit similar to when you want to increment I by I plus 1, something like that, right? Similar, but now we just want to reassign the address. Let's now have a look at the right-hand side, and then I'm going to give you a similar question as before. Okay? So now let's go over very quickly. So we got a method over here for the caller, and then we have, again, U is the context objects over here. And then we are trying to create just a new point object P and then 3, 4. Okay, let me draw that right away. So what we have is P is now pointing to a point objects. And let's assume we got X and Y, and then we got 3 and 4. Okay, 3 and 4 over here. Okay. And then let's not worry about line number 5 just for now. Okay, you can read it later. It's just for the convenience for testing. Let's not worry about it. Now let's now focus on this particular line. Okay, the next line. If you look at this line here, let me highlight it. The orange one. We're going to call the method that we just went through on the left-hand side. Now here is my question for you, okay? Without going further, I'm going to post my question over here, okay? After line number 6, is P going to point to the same objects? Okay, I hope that's readable to you. Okay, that's my question. After executing the code on the right-hand side, is specifically after line number 6, is P over here initially pointing to this particular object over here? Is it going to be reassigned to something else? That is my question. Okay, I have such suspicion simply because when I look at the left-hand side, this is a method that's being called. It is going to reassign whatever that's being passed, being Q over here, to something else. That's why I'm wondering if that should be the case. Okay, good. Do you think yes? No. Yes, no? I heard no. Anybody think yes? It's okay. It's not a test. Anybody who might think yes, yes? Really? Okay, maybe just shy. Let's see what's going to happen. The answer is, as Stephen said, it's going to be no. It's not going to be reassigned because of the following. Okay? Again, if you want to analyze such problem over here, the principle is the same as the first step. What you have to see is when you try to make this method call, right? We are trying to pass the P. P over here is the arguments. And then the Q over here is the parameter, as we said, okay? Implicitly, there is going to be an assignment, okay? I'm just going to make it over here, right? It's going to be Q is assigned to P. That one is really critical, right? That's the key. Now, as we learned very well in the first few weeks, this is going to create an alias for P, right? So that means Q is now going to point to wherever P is going to point to. So that means Q is now pointing to wherever P is pointing to. Okay? That's basically before you try to execute the first line of that method. Okay? And now let's go on a little bit more. Okay? I'm going to switch the color. Let's say we try to execute this first line over here. We simply got MP. MP is now going to store the address of a new points, and it's going to be 6 and 8. Okay? So I'm going to say points where X and Y will just be 6 and 8. Okay, sorry about that. 6 and 8. And then when we say the second line over here, that's where my suspicion came from. When I say Q is assigned to MP, am I changing P? Not really, right? I'm saying Q, rather than pointing to where it is currently pointing to, it's now going to point to wherever MP is pointing to. So now Q is pointing to over here, whereas P refer to the same object as before, just the same. Guys, are you comfortable with this? So this is a very common misconception about call-by-value, especially when your argument is of reference type. So here's the principle. Okay, I'm going to write it down for you. Okay. The principle is, let me just see, maybe I'll write it here. When the parameter is of reference type, do not try to reassign it. Because it's simply useless. Because whatever you're trying to reassign is simply the local parameter over here. It's not really the P that you talked about in the beginning. Okay? That's the principle you want to remember. Okay? So every time when you're trying to see your method over here, if your parameter is actually of reference type, and you notice that maybe sometimes by accident, you simply try to reassign your parameter, you should know that it's not useful. It just cannot be done. Okay. Are we okay with the first case? So the follow-up question is, if we are not supposed to reassign the parameter when it's a reference type, what can we do about it? Right? Well, we learned about aliasing. What's really unique about aliasing? Aliasing simply means you got more than one more than one copies of the same address. Using either one of them can actually modify the same objects. That's exactly what we can do over here. Given that Q and P, they store the same address, agree? First of all, initially, I'm talking about the initial case. In the beginning, P and Q simply point to the same objects. In that case, we can simply use Q to call some mutator method so that we can modify this particular object. That's what we can do. Okay? That's the second example I would like to go over with you. Okay? The first one, just to show you there's a common misconception. Don't do it, because that's useless. The second one is something you want to get used to. Okay? You're going to see lots of use cases like that later or in the lab. Okay, let's see the second one. The second one, somehow the setup very similar to the first one. Okay, but let's still go over carefully. Again, I want you to pay attention to this particular method, please, over here, right? It's called change via some reference, okay? And then, again, the parameter is a reference type, it's a point, the same class. And then we simply try to do the following. Let's assume, quickly, where we have the point class over here, we got a method called move vertically. We got another one called move horizontally, in which case you simply increment y or increment x accordingly. Okay, that's very easy. Okay, I wouldn't bother you too much by that detail. Okay, what we want to see is if we try to call these mutated methods instead, rather than reassigning the reference, what's going to happen? Okay, we're going to see that. Okay, let's set it up. You got the context object over here, and also you have this particular points that we're going to create. Let's do it. Okay, so what you have is P is now going to point to the point class over here, as we did before, 3 and 4, x and y, 3 and 4. Okay, very good. And again, for line number 5, I'll leave you to study why it can be used for testing purpose. For now, let's not worry about it. Okay, I want you to focus on this line number 6. Okay. Now here's my question. So now this kind of question becomes a little bit more sophisticated. I got two parts of the question. Okay, I'm going to write it down. So now let me put it over here. Okay, after line number 6, okay, part A of the question is P pointing to the same object first of all. Okay. Number 1, and part B is the objects pointed to by P initially modified. When I say modify, I simply mean the attributes of that method. Basically, we know that P initially is pointing to this object over here. Somehow, are the x and y, or both of them, somehow be changed by this method call. Okay? So these are the two questions I pose to you. Okay? Think about it. We got A and B. Okay? I can give you a little bit hints over here. If you look at this method here that we're considering that's being called, you can see that there is no method reassignment because we know that it's useless. That's why now we are doing it. Okay? So I would say for K, A is pretty much a no-brainer. Okay? It's simply just it's yes. It's just going to point to that object. It's the same. Okay? For P. Number 1. Yes. Okay? That one I can tell you right away. Okay? You don't have to be bothered by that. What about B here? Notice one thing here. So here, it is true we are passing P as an argument. However, over here, we're using Q, seems to be a different variable for sure. And we are trying to say now, move horizontally by 3 units on Q, and then move vertically by 4 units on Q. It seems like we're only going to change Q are we going to change P at the same time? That's a question. Yes, we agree? Okay, the answer is yes. Okay, let's see why. Okay, we're going to visualize this quickly. Okay, the answer is yes. Very good. Okay, you're going to see lots of cases like this. That's why I want to go very thoroughly with you. Okay, let's see. Again, if you look at this particular part over here for the method call, when we call this with P, implicitly we're going to have Q is assigned to P, right? So that means Q is now going to point to the same object. So now we got aliasing. P and Q point to the same objects. And now when we say Q, let me highlight it. The first one, when we say Q move horizontally by 3, that one is going to change the X value. In that case, it is going to change this particular object that's pointing to by Q. At the same time, it's pointing to by P, right? So that means after that, we're going to change the X by 3 units, so from 3 to 6, okay? And then the next line will be something similar, okay? Let me use a different color. The next line will be Q move vertically by 4 units. Again, Q is referring to, again, this object over here. And then if you try to increment by 4 units, you're going to say incremented by the Y, by that units. So that'll be from 4 to 8. Okay? So for part B, yes, it's going to be modified. It's going to be modified this way. Okay? Again, I'm going to leave it to you to see why the line number 7 and line number 8 would be the case. So both assertions pass over there, just to make sure. When you have callbyvalue and this reference type, and you're trying to call a mutative method, it's not going to reassign the objects, but it's going to modify the contents of the objects themselves. That's the whole story about callbyvalue. Okay? It's not that difficult. You just have to make sure you always remember to analyze this. Remember the top, the implicit assignment. That's really the key. Okay? So this implicit assignment is really important, okay, to always remember. Okay, any questions? Okay, that's good. I'm going to remind you more about callbyvalue later when we talk about aggregation and composition a little bit later. Okay, let me switch to another topic. Okay, and I believe your coming lab is going to be about Java collections. I'm not exactly sure which collection you're going to be using, but I'll just introduce 2 to you anyway. It'll be the same principle. Otherwise, we can talk about more in the class if you run into difficulty when doing lab. Okay, what I would like to do is switch the topic into collection quickly. Let me just move that. Okay, sorry, cancel. Okay, Java collection. It's not a difficult concept, actually. Maybe many of you have actually used that already. Okay. Specifically, I would like to talk about ArrayList and also Hashtable. We talked about Hashtable previously when we talked about hashcode. So I'm going to give you some example and go over together. But I think the most important message for this lecture is we're going to give you a little bit of flavor about something called generics, generic parameter. You're only just going to be a user of a generic parameter. You wouldn't know what's the rationale of having those parameters. We'll talk about them once we get to inheritance, a little bit later, but not now. Okay, but just to give you some intuition. Okay, let's go over some slides very quickly, and then we'll go to examples. Okay, so we're going to see method header. We actually mentioned the header, the word header before. Basically, what's the return type, what's the parameters, and what's the name of the method. We're going to see that. That's exactly what you would see in Java API for the library. And also, we're going to see parameters versus argument. Again, we just review it, so that one I can just leave you to read it. And also, I want to give you 2 examples about how you can explore the API in Java, ArrayList and Hashtable. Specifically, when there are generic parameters, how can you understand the E, for example, when you see ArrayList? I'm going to tell you that. Okay, we'll get there. Okay, that's kind of the learning outcomes for this short lecture. Okay, why are we doing the API? Okay, after all, Java is a very common language where they got lots of users. They got a very rich community. So people usually find that problems simply reoccur themselves over and over. So they simply develop solutions that can be reapplied to similar problems. In your case, before lab test 1, I kind of forced you to actually use primitive array. It has a reason, because when you just try to learn the basics, it's always nice to learn to build things from scratch. But now, in other cases, you may just want to use other people's work. That's allowed. Okay? It's not considered as cheating. It's not. Okay? Depends on how we define that. Okay, so when you get more experience, let's say you're doing a senior year software projects, you may not just want to implement a list by yourself. You may just want to use ArrayList or array. Okay, rule of the thumb: do not reinvent the wheel. It's a well saying, right? You don't want to do it when there's something available for you. Okay, it's an API, just for your information, standing for Application Programming Interface. Okay, you can simply reuse them. They're pretty much stable, and they may be kept up to date as well. Okay, so now we're just going to talk about 2 classes only, but they got lots of resources over there. So feel free to go for the link and see which classes you might be interested. Okay, that's something I'll leave to you. Okay, we're not going to cover that many in the class. And every API you see for each class is simply going to give some description about the class and also give you a summary of the methods. And the most important thing is they don't show you the code. They only show you the methods you can call on those classes. That's the important stuff, right? As a user, you don't have to know the implementation details. Okay, now, every time if you want to use a library, of course, make sure you put an import statement here. So the util package is a very large one, containing many useful classes. You can simply say import java.util.star. That's going to cover everything. But now I'm just being specific, just ArrayList. Okay, and then how do you use it? The principle will be very similar to how you manipulate objects when we talk about a review. Every time you want to use a library class, let's say ArrayList, first of all, declare it. And then create an object as a context object, and then call methods. And the method can be either accessor or mutator. The same principle applies. Okay? Now, the only thing that's really mysterious to us is what does it really mean? When we say ArrayList, after that we say string. That's the thing we want to demystify. Okay, in just a moment. Let's not worry about it. Just make sure you're aware there's such thing of string or something else you have to put when you declare Java collection. Okay, for this slide here, I'm going to leave it to you. I'm not going to bother you with that. Basically, just review the idea about classes versus methods and also arguments versus parameters. Okay, I'm just going to skip that for now. Okay, but the most important thing you should know is if you want to create instances, you have to declare and also use a new keyword and call the method. Okay, that's easy. Okay. Oh, one more thing to say. I mentioned that. Remember we talked about static versus non-static. Also in the Java API, I would say most of the classes and methods, they are non-static, which means you must create a context object like the list over here. You have to create it in order to call the methods. In other cases, the methods might simply just be static, in which case you don't have to. For example, you must be very familiar with this class over here called math. Every method in the math class is static, which means you can simply use the class name math. Okay, that's something very quick reminder. Okay, also we got parameters versus arguments. Okay, I'm gonna let you read over this. We just review in the Callbyvalue lecture. I don't need to trouble you with that. Okay, but just make sure you read it, please. Okay, also the header. What's really important about header is the only information you'll be given, mostly in the API, is the header for the methods. So that one doesn't show you any coding details. Okay, that's not something you would know as a user. Okay, the name of the method, also input like parameters, and also the output return type, which can be void, of course. Okay, we're gonna see examples. Okay, and we're gonna see summary. Okay, so far just a very quick catching up with the background. Let's see examples. Okay, the first example I would like to talk about is ArrayList. Okay. ArrayList is similar to an array. So I just put some informal description for you over here. It's basically a resizable array. Think about how you actually apply the programming pattern for programming lab test 1. You have an array primitive with a fixed size, let's say 300. However, we never talk about what if I store 300 objects already. I want to add 300 first objects into the array. I never said that. All right. If you really want to do it, you have to extend the array manually. But that's not something we'll talk about now. Okay? But the advantage of using ArrayList in Java is you don't have to worry about such upper bound issue. You can keep adding stuff until you're satisfied. You're never restricted by how many elements you can add in. Okay? That's something to note. Okay, so now I'm going to go over this with on iPad with you. When you see the slides, I simply just choose a small number of methods here that's commonly used. We're going to go over them, some of them, and use examples. But I will really encourage you to really click on the link and see what's really available there for ArrayList. Okay? What I want to start with, first of all, okay, is to talk about generic parameters. Okay, I'll talk about it. Okay. So this is just a snapshot of part of what you will see in the API. Okay, so now let's see what, and then I'm going to explain the generic parameters in a little bit more details. Okay, I think that's the most important thing for this lecture. Okay, you can see we talk about ArrayList, and then we have different methods here. We got size, we got add, and also we got remove, and we got index of, and get, etc. Okay, every time if you look at a particular method, number one, you want to read the description. For example, for the size, it will simply tell you the number of elements in this list, right? No, presumably, they should really give you some informative description so that you can try, okay? May not be precise, but should be informative enough. So now, I want to ask you about, well, I shouldn't really say I ask you because you may not know. I'll point to you where we're going to go over in detail. Look at, first of all, you can see integer, you know about it, it's a primitive type. Also, you got Boolean here, you also know about it, it's also a Boolean type. However, what happened to, I'm going to do a different color. We see E over here. Is E an existing class in Java? Not really. There's no such class called E. You can create one, but I can tell you that's not a class, at least for now. Okay? You can see, we see E here, and also you can see the return type is E here, and also you can see another return type being E here, and also argument type is E here. We got 4 occurrences of the letter E. Okay? Let me just say a little bit more, and then we're going to see exactly how to understand this. So here, the E, they are used as parameter type. And also the 2 occurrences of E here, they are used as return type. But now the problem is, as I said, E is not really an existing class. So what are we talking about over here if E doesn't even exist? Okay? That's my question. Okay? We're going to answer to this question in the next illustration. Okay, everybody's okay with this? Okay, I'm just trying to tell you that you can see we're using E since to be consistent throughout as a return type or as a parameter type. But what does it really mean? Does E really mean a string? Or does it mean integer? Or does it mean points or any other class? The short answer is it can be anything. But it's decided by whoever is using the array list. So what do I mean? Let's see. Let's now go to the illustration, the next slide over here. Okay, I just present more like a normal class. Okay, it's not exactly a valid syntax in Java, hopefully just for illustration. I want you to consider if you were to declare the array list class yourself, or at least to see how the developer defined the array list themselves. How would they do it? They will simply say, I got a class called ArrayList, and then I got something over here. I'll explain this in just a moment, okay? We got something over here, and then I got add, I got remove, I got get. Let's say we focus on these 3 methods. And here the parameter is simply of type E. And also the return type is simply of type parameter E, okay? So now, this is where the things go a little bit new to you. Okay, let's try to focus on that. So now here's the syntax. You can see we got over here, I'll put it here, angle brackets, and then we got E here, we got angle brackets over here. Okay, so this is so-called generic parameter. Parameter for what? Generic parameter for some type that will be instantiated by users of ArrayList. I'll show you right away. You can see over here, so I simply call it caller. Caller are also users, of course. We have list number 1, we have list number 2. They are separate calls to the array list, basically, right? They're simply different variables. You can see for the first one, I'm saying that I'm trying to declare array list over here. However, what's inside over here is different. For one case, it's string. The other case is called points. Okay? And then if you look at the right-hand side, the right-hand side, you simply just put something that's consistent over here because we're trying to create an empty list at the right-hand side. Okay? Let's notice that first. Okay, so now you can think about this is user 1, and this guy here is user 2. Two different users of the same class. Okay? So now let's talk about what's the consequence of giving different instantiations of the types. One is called string, the other one is called points. Okay? Let's go back to the ArrayList class. This E over here, notice that is for declaring a generic parameter. Okay? Generic parameter. So now here's the important thing. All the other occurrences of E, they are usages of E. Okay? I'm going to say over here. Okay, let's see here. E here, and E here. All these are referring to usages. So they are simply usages of E. That means when you are defining your class for ArrayList, you simply say whatever E that might be instantiated into, for example, it might be instantiated into a string over here, or it might be instantiated into a point. I'm simply referring to that particular class. Okay? As far as the user is concerned, that's all you have to know. Okay? I'm going to give you a little bit more exploration. But later on, we're going to talk more about rationale. Why do we need generic classes? Maybe a little bit later when we talk about inheritance. Okay, so now let me show you how a little bit more obvious to show you more straightforwardly how things will work. Okay, so now what I would do is let me just first of all I'll copy this guy here. I'll make a new page. Okay. Okay, these are the new two colors, and then also for cleanness, I'm just going to copy this page as well. This diagram. Okay, let's start clean over here. Okay. The top is the class, the library class. The bottom there are the two users. Okay. So now here is what's going to happen. Okay. Let's talk about the first one, user 1. When I say ArrayList string and then list 1, over here I'm basically saying E over here is going to be instantiated by string. Effectively, this is how you can think of it. You can think about Java at a runtime is going to make a copy of the same class over here. Okay, just make a copy. And then the E that we talk about over here is now going to be instantiated by string. Consequently, every occurrence of E in the same class is going to be replaced by string. This is something that's done implicitly by Java automatically. You don't have to do it by yourself. Actually, you should feel lucky, because if you had to do this manually by yourself, then every time if you want to have a different type of array list, you got to create a class yourself, but you don't have to because of generic parameter. Similarly, when you look at client number 2, if you look at that array list, and then now I simply say points, and consequently, what's going to happen is Java at the runtime is simply just going to create another class over here. And then it's going to instantiate over here E by points. And then every occurrence of the E over here is going to be replaced by points. Okay. One is orange, the other one is pink. Of course, any caller, any user can choose to instantiate the E by just different type as they wish. Okay, it's completely up to them. Okay, guys, are we okay so far? Yes, question.
Can I not have an array list which can store multiple advertisements?
Good question. The question was, can you actually have an array list where you simply store different types of element? Maybe you want to store points and maybe also string at the same time. I would say it's possible. Okay, let me tell you the solution right away, but to explain it, maybe we can revisit that a little bit later. Okay, so to really answer your question, that might be nice to know anyway. Okay, you can simply say I can have another user number 3. I can simply say over here ArrayList and then objects. Guys, you remember objects? It's a class that's somehow the minimum that's common to every other class, right? Where we got an equals method and a hash code method. You can simply put objects over here. The consequence of that, let me say let's call that is list3, is new, okay, with some consistent writing over here. For list number 3, it's a very accommodating list, which is going to store any kind of objects, okay? However, it's a bad practice to do so, okay? Because you're going to do lots of casting when you want to retrieve things from the list, which we'll talk about later after we talk about inheritance. I'll definitely revisit this point. It's really important, okay? But for now, it's okay, just for your knowledge. If you really want to have for your lab, have a very accommodating list which can store many types of elements, you can say array list of objects. But just remember, it's a bad practice, okay? Okay, good. So now, let me try to reinforce your understanding a little bit. I'm going to write some fragment of code for you. Because I got list 1 and I got list 2. I got 2 variables. Let me try to call some methods on them. You just tell me whether they're going to compile or not to compile. That's all I want to know, okay? Exactly how they behave, we're going to see in the next illustration. But for now, compile or not compile, okay? Let's start with something simple. Okay, I'll just have 2 lines for you. Number 1, if I say list 1 dot add, okay, and then I would say new points. Remember anonymous object, right? Okay, hopefully you're comfortable with it. Number 2, if I say list number 1 dot add, and then I'll simply say, how about 3 and 4? Okay, it's a string. Okay, and then I'm going to be a little bit lazy over here. Okay, I'm just going to create another 2 over here, and then I'm going to call this 3. I'm going to call this 4. However, I'm going to change the context object over here. So the last 2 I'm trying to create, they should be list number 2. Okay, you got 4 lines over here. 1, 2, 3, 4. The first 2 are using list 1 as a context objects. The last 2 are using list 2 as the context objects. Number 1, number 3, the arguments are point objects or point addresses. Number 2 and number 4, the arguments are strings. Okay? Now, do you think they should all compile? I heard no. Okay, that's good. Right? That's good. Okay, Stefan, just hold it. Okay. How about number 1? Should number 1 compile? If you believe no, can you explain to me why? I'll give you a little bit of hints. How you actually instantiate the generic parameter E when you first declare list 1 is crucial. Do you see my hints? You want to explain to us?
This one stores a string, like line 1 gets a new point.
Exactly, that's inconsistent, incompatible. Exactly right. Okay, that's exactly right. Okay, now let's see that very quickly. If you look at that over here, first of all, list 1 was declared over here where we instantiate the generic parameter by string. So this is exactly this version that we talk about over here, right? In that particular version, the E over here has been replaced by string. Agree? So that means for list 1, it can only take string to be added. In that case, is this a string? No. So that would not compile. Similarly, would you agree this line over here also would not compile for a similar reason? Because list number 2 was declared where E was instantiated by points. So that means we're talking about this particular alternative version where the arguments over here, the parameter should be of type points. But now it is a string, so this will not compile. So 1 and 4 will not compile. Okay? Question, please.
So, as far as I remember, when we were going over the API, one of the add methods, I'm not sure which one, was a boolean, not a
yes,
void.
exactly. So what Stefan was talking about is just a little bit more detail about the API. Okay, so if you look at the API, I'm going to come back to this point a little bit later. Okay. Okay, so one thing you can notice, you're exactly right. So now we talk about the array list over here. Okay, that's the class we're talking about. If you look at the add method, notice that the return value, the return type is not void. I would say from the design point of view, it should be void, which means I'm adding something to it, like add points, add students, etc. Right? It should be void. However, it's their design decision, just nothing we can do. As a user, either you use it, accept it, or you don't use it. Right? So now it's simply going to say appends this specific element to the end of the list. If you want to see exactly why, under what circumstance you're going to return true or false, you can simply click on this particular add and see more details. Okay, you can see that, yeah. Okay, but I would say that's not the main point for the discussion. Okay, guys, I want to make sure you're at least more or less comfortable with the final decision here. 1, 2, 3, 4. Why number 1 and number 4 would not compile, whereas 2 and 3 should compile. That's really important. Okay? Okay, I assume you're okay. Otherwise, speak to me, okay, after class. But I would say having this kind of the imaginary thinking at the bottom here, thinking about alternative versions for the classes, that's really important. Otherwise, you cannot judge whether the same type of array list might compile in one case, but it may not compile in the other case, simply because it is instantiated differently. Okay. Okay, let's go. We're gonna do a little similar exercise for hash table, but before that, let's have a quick look on an example over here. Okay, basically this I'm gonna make the source code available to you as well. Okay, I'm gonna make it bigger. We're gonna do one line at a time. We may not go over all of them, but I'll just give you some idea. Array list is very easy to trace because you can think about it, it's like an array. You just have to be flexible with the indices. I'll show you what I mean in just a moment. Okay. We're going to look at them. I'm going to go over just a few lines, just enough, so you can trace the rest. Also, you can play with the source code. Okay. Okay, let's try this now. Okay. So now, let's see. First of all, you can see we got an import over here. Okay. And then we have a main method just for console tester. Okay. You can write a JUnit if you wish. That's not a problem. Okay. This line is important. You can see this is one user, where we are trying to instantiate E by string. So that means every element stored in this particular list is now going to be a string. If you want to add something to it, it should be a string. If you want to retrieve something back, it should also be a string. Simply because if you remember over here, in the API, you can see get is going to return E. In this case, E will be a string. And also, you should add also E. In this case, E will be a string. Okay, just very quickly. Okay, let's go back here. Let's just trace this very quickly. What about the first line? The first line here, we simply say it's going to be a list. And then, when you actually simply call this particular constructor without any arguments, it's simply going to create an empty array list. Okay? So that means you can think about initially list is just pointing to, I'll just say like this. Okay? Like a vertical line, just say it's empty. It's not null, but it's empty. Okay? Somewhere. Okay, so now if I say print line, list.size, obvious should be 0. Agree? And also contains, list.contains over here. So does A exist in the list? No. So should be false. Very straightforward. Okay, now this one is interesting. When I say index of, that sounds familiar, right? For those of you who actually still remember the birthday book example, we got an index of method, right? You may try to recall a little bit, right? You might need to do it again later, maybe. So now here, index of A doesn't exist, so that should be -1. Okay, I just followed the same convention as Java. Okay, doesn't exist. All right, -1. And now let's try something more interesting. When I say list.add and list.add, the principle is easy. Pretty much like how the programming pattern works. You just append to the end. So when I say list.add A, it's simply just going to add A, first of all, and also add B, append B to the end. And one thing to say, indices start with 0, 0 and 1, okay? Like an array. Okay, so now if I try this, list that contains A in this case should be true. Agree? Okay, A is there. Also, list that contains B should be true. And also, list that contains C should be false. Okay? All right, very easy. So now let's see one more, okay? Let's see some addition and some removal. I want you to look at this line over here, please. The pink one, line number 12. This one here is an overloaded method, meaning that we are still calling the add method, but this method here takes slightly different types of parameters. It says that we're going to add C to the list. However, the first parameter there is 1. So what does that mean? That means we want to add this particular C into a specific index into the list. And that index should be 1. Okay? So now, how do we visualize that? That's the tricky part. Okay? Let's see that. Okay? You know what? I think it might be the best for me to illustrate this a little bit below here, so I can move things. You really want to see the visualization. If you don't mind, I'm going to reproduce the list over here. So we got a list pointing to, so far we got A and B, okay, from the previous code. And then also indices 0 and 1. So now I want to know what's the effects of executing line number 12. Somehow, conceptually, we want to insert C in index 1, somewhere between these two elements. Okay? So how you can think of it is like this. It's simply going to somehow shift everything to the right of the destination index by 1. So what it will do is it's simply going to shift, oops. I'm not sure how well I can do this. Okay, imagine there's a shift, okay? And then, so this should become 2 instead, right? And then this is index 1. And then we want to insert C into index 1. So C is now over here. So this is what happened when you try to add to a particular index 1. Okay? Sorry, the drawing is not really perfect, but that's the best I could do. Okay. All right. After this, of course, you can simply try to do things like, you can try to see, does it contain A? Definitely yes. You can do other inquiries, as before. Let's do a final one. Okay. What about list remove C? Okay. It's following a similar principle. Okay. Whenever you want to remove something, you simply give whatever element you want to remove. If C exists in the list, you're going to remove it. If it doesn't exist, do nothing. Okay. So now C does exist. Okay. Let's see that. So C is exactly, okay, we talk about this line here. C exists exactly over here. How do we remove it? The way to do it is like this. Conceptually, we are wiping out C over here, and then shift everything to the right, to the left, like that. And of course, this should remain to be index 1. Of course, all these such indices reset will be done by Java. Okay, you just have to know conceptually how this works. Okay, but I'm pretty sure, given what you have done for lab test 1, this is not difficult to implement. You should know, have an idea how to do this by a loop. Okay, okay, we have gone over how you can create an empty list, the basic queries, how you can add to the end, or add to a particular index, or how you can remove, things like that. Okay, any questions about ArrayList? It's pretty easy idea. Okay. All right. Okay, one more thing to tell you. Okay, how do I go over the list? This is one way to go, just using what you have known already. So you can simply say, I want to have a loop counter I starting with 0, and then it should be strictly less than list. Notice that if you simply say list.length, is it going to work? No, right? Because length is only for primitive array, right? It's not going to compile. You had to use that size. It's a method call. Okay, you can use that. Okay, that's one way to do loop, and I have recorded some tutorial videos for you to go over ArrayList and Hashtable in more depth. So that's, the links are at the end of the lecture. Go over them. It might be useful for your labs. Okay. All right, any questions so far? We okay? All right, very good. Let's now do hash table very quickly, okay? Again, we're going to revisit the concept that we just talked about, generating parameters, and also how you can instantiate it quickly. Okay, everything I said about instantiating the generic parameter is here, okay? Nothing has been skipped, okay? You can go over the slides. As an example, we just went over. Okay, now what about hash table? Hash table basically should be no surprise to you. We did go over 1 or 2 lectures on the idea, but just as a brush up. Hash table is basically 2 columns. You got keys, you got values, okay? The important thing about the keys is there should be no duplicates. Okay, you can see Alan, Mark, and Tom, okay, no duplicates. And also for value, you may contain duplicates. Let's say the values over here are simply letter grades they receive. Both Alan and Mark, Alan and Tom, they might receive the same grades, nothing wrong, okay? But different persons might receive the same grades. Okay, and also the key is going to be used to uniquely identify some row. Right, we talk about this idea when we talk about map. So hash table is a very efficient implementation for map as opposed to the linear solution that we talk about in the class. Okay, that's a very quick review to remind you. So now I want to do a very quick similar exercise with you over here. Okay, so again, this is only some common methods you may call on the hash table. If you also refer to the tutorial video link at the end of the lecture, you can also see the link. Okay, just follow the tutorial video. That will also help you. Okay, let me just point to your attention over here. Look at this. Things seem to get a little bit more complicated as before, a little bit. Size return integer, okay? Contains the key, takes objects, returns Boolean. That's fine. But now look at this. The put method is simply going to put a new key and value pair. For example, let's say Jackie getting F, for the course, something like that, right? You can put that into the table if you want. And now, let's say for this particular method here, look at the K here and the V here. They do not refer to any existing classes, do they? They don't. However, what can we do it? We can do it for the same reason as before. Simply because, imagine that, I'm going to show you, when the developer declared their hash table class, they got 2 generic parameters. One's K, the other one called V, so you can refer to them, okay? So notice that you got K and V here. Also, you got V here. Okay, so we got 2 generic parameters. You got K, you got V. Okay, let's go a little bit more details into this. Okay, so now you got your hash table over here. There's a class, and now we got K and V. So these are generic parameters. You just declare them. Every time, it's easy for you to see if you got the angle brackets over here, so whatever you put inside are the declaration for the parameters. So where are the usages of them? So now let me just highlight to you. So you can see V here, K here, and V here. So these are the usages for the generic parameter. Okay, I'll put it here. V here, K here, and V here. So these are the usages of the generic parameters. So that means when any caller, when they actually instantiate the K into something and V into something, it's going to affect what V and K, that's highlight yellow, really mean. Okay, let's see some example quickly. So now, let's have a look, and then we're gonna switch the context. We're gonna make it a little bit cleaner for you, okay? This is number 1. Number 2. Notice that I intentionally put string first, integer second. And here I put integer first and string second. Imagine what difference it will make. Imagine that. Okay, we're going to see that exactly. Okay, I'm going to show you. Okay, so now let's copy these 2 diagrams again, just to make it absolutely clean for you. So these are the 2 users of hash table. And let me also put this guy over here in there, okay? To do a similar exercise as before. Okay, like that. Okay, the top is the declaration from the array from the hash table. Okay, we got K and V. So now let's look at the first user. I'm going to use red. The first user. Notice that we have string and also integer. So now how you can think of it is, under the hood, implicitly, Java is going to create a alternative version where, notice that k is going to be instantiated by string. If you don't mind, I'd simply say s for string, just to save my writing. Okay, and also v is going to be integer. Okay, and then consequently, every occurrence of k is going to be replaced by s, string. Every occurrence of v is going to be integer. Integer and integer. That's for version number 1. Are you okay? Okay. Let's see what difference the second version is going to make. Okay. The second version over here, the second line. Okay. Let me use a pink here. Okay. What we will do is, let's implicitly, it's just going to be, I'll put it here. How about that? It's just going to be another version over here where, let me switch to pink. Okay. So now you can see the first one is going to be integer and the second one is going to be a string. So k is going to be instantiated by integer, v is going to be instantiated by string, right? So now every occurrence of k will be integer. Every occurrence of v will be string. So now, hopefully you can see the very important difference over here. If I say t1.get versus t2.get, are they going to return different types or the same type? Would you say the same or different? t1.get? Well, let me make it clear. If I somehow you just couldn't understand my question, that's fine. Okay. Let me now, first of all, let me start with something small. Okay. I want to make sure you really understand this. Number 1. Okay. If I say t1, okay, t1 is here and t2 is here. Okay. t1.put. Let's say, let me say Alan, 34, okay, integer. Number 2, if I got t1.put, 34, Alan. Number 3, I'll say t2.put, Alan, 34, right? Again, I want you to tell me only if the line should compile or not. That's the only thing I want to know. How they behave, we'll see that in the next slide. 1, 2, 3, 4. Okay, that's good. Okay, I can see you're trying to think. That's very nice. Okay, should 1 compile? Yes. Okay, let's see why. Very good. Okay. So now what we would see is over here, T1, we know that the k was instantiated by string, and I was instantiated by integer. So now when you see the put, it's going to take string followed by integer. Is it string, integer? It is. So check. On the other hand, when you put integer, 34 does not match with the string. Okay, so doesn't compile. We okay? Good. So now for similar reason, so now should number 3 compile? No. Okay, let's go over it very quickly. So T2 is over here. So now you can see the string, the k is instantiated by integer over here. And then v is instantiated by string over here. Okay, integer and string. So now when you talk about a put, it's a different version, should we say. A different version where key should be integer and value should be a string. So now is it integer and string? No. So doesn't compile. Integer and string? Yes. So this is a very important concept to grasp at this level. Yes? I said T4? Oh, I meant I think I meant T2. Yes, very good. Of course, it wouldn't compile. The variable doesn't exist, right? If I put something like this in the test, don't worry, you will get your marks. If you say T4 doesn't exist, that will be fine. Not a problem. Thank you. Okay, any questions, please? Okay, let me just say one more, okay? One more. And then we go over a little bit about Hashtable, and then hopefully we can talk a little bit about recursion. Hopefully, I don't know. We'll see. Okay, so now let's say we got t1.get. t1.get, let's say I want to get what's in Alan versus t2.get. Over here, I'm going to say 34. I can tell you that both of them actually compile, simply because the reason is a little bit different. You can see that for the get method in both versions, if you look at the get, the parameter type is simply just object, which means anything will be okay. Okay, so compilation is a no-brainer for these cases. But now, I want to know what's the return type for each one of them. What's the return type for t1.get? Is it a string or integer? Integer. Look at that, right? If you look at that, it's an integer. Okay, integer. And t2.get, I should look at this version over here. That should be a string. Okay, it's a final reinforcement. Again, if you want to really master this kind of analysis, number one, you want to go over just a reasoning process I'm trying to go through with you. Being able to think about the imaginary two versions over there, depending on how the caller instantiated E, the K and V in this case, is important. Okay. Once you have done that, do some substitutions, and you should be ready to get a set. Okay. So now let's do a quick example about hash table. Well, many things you have known already. So hash table is not difficult. Okay. Okay. So now let's have a quick look. Okay. Well, how do we visualize a hash table? We just draw a two-column table. Okay, so now let's go over very quickly. The first line over here, line number 4. Okay, so here we simply say grades. For simplicity, the key will be string. The value will be also string. Okay, just make it easy. So now it's simply going to be an empty table to begin with. Okay, size of the table 0, right? No entries have been stored just yet. And now you can actually see whether we call it grades table, right? It would be the person's name being the key and also the grades they receive being the values. Do we have Alan yet? No. Do we have B plus yet? No. Notice that you can either say contains the key. The key is in the left column. So what I mean by that is if you look at the column over here, the table over here, the keys are the left column. Okay, the values are on the right column. Okay, that's why I drew this in the very beginning. Okay. So now, contains Alan on the left column, no. And also contains value, you can also say that these are in the right column, the right-hand side. Of course, in both cases, they should just be false. Okay, I want to do just two things very quickly. How do you visualize the put method over here? Okay. Alan A, Mark B plus, and Tom C. Okay, so what you will do is you can think about the grades is simply just a address to some table. Okay, two columns, and then I'll say A for Alan. Actually, let me spell it out. Otherwise, you may have some confusion over there. Alan, and also you got. You know what? I want to do this properly. Sorry about that. Okay, so now let's see how we're going to do that. So we got the grades tables over here. Okay, two columns. The first one, Alan, and then A, right? So you simply put Alan inside, and then the value should be A. And also Mark, and then B plus. Mark, and then B plus. And also you got Tom, and then C. Okay, very good. Okay, that's what we got so far. Okay, you can simply do some very simple inquiry. For example, do we contain the key Alan? Yes, exactly over here. Do we have the key Mark? Yes, it's exactly over here. Do we have the key for Tom? Yes. Now, do we have the key Simon? No, so false. Okay, notice that. Okay, you can do contain value as well, similarly. Now, I want to do a final thing to show you that's interesting. I say grades.put Mark F. First of all, does mark exist as a key? It does. So what should be the consequence of doing this? I'm basically saying I'm not trying to put in a new row into the table because mark is already occupying this particular row. And I'm not adding a new row. What I would do is, so whenever you have this particular call to the put method, okay, I'll set it over here. In this case, mark is an existing key. In that case, overwrite its value. So what you would do is simply changing his grade from B+ to F. That's what you're doing. You're not growing the size or shrinking the size of the table. You're just changing whatever return value it would be from mark. That's what you're doing. Okay? So if you look at the print statements I put around, you will see the difference. Okay? I'm going to make the code available to you. Play with it. Okay? I think your collection classes are very useful beyond this course, for sure. Okay? Okay, I think that would be about it for collections. A very short lecture, but I think the main lesson is for you to know this kind of exercise about compilation. Okay? The guy over here. Okay? I think that's the most important lesson to learn from this particular short lecture. Any questions? Yes? Can you have multiple marks? Okay, good question. So, okay, let's think about conceptually, right? Okay, everything should go logically. You're basically asking, let's say we got this table over here, can we have simply another row, and then the key will simply just be mark? That's what you're asking, right? Well, remember we said no duplicates for the key. So the answer is no. So that's why when you try to put in mark with F, it's not going to add a new row so that we got duplicates. It's simply going to override it, right? Was there a question? Yes, please.
For the get method,
yeah.
would you be able to set parameter to k rather than object?
Oh, good question. Okay, it's a very good question. You're basically asking about, I agree with you. Let me just get this clean and then I will show everybody what you mean exactly. Okay, so this is the like a slice, a shortcut, a slice of the hash table class. What you are concerned about is the object over here. You're asking, would it be okay if we change this to k? My answer is, if you're designing your own hash map or hash table class yourself, by all means do it. Yes, it's a very good design principle. I'm saying if you instantiate k to be, let's say, points, then this object here, rather than object, would be point accordingly. Okay? Somehow, for some reason, the hash table class in Java, they chose to have objects. That's their design decision. Again, as I said, either you don't use them, use your own version with k, or use it. Right? Yeah. Good question. I would say, yes, do this if you are defining your own generic parameter. Yeah, so I think in the later labs, I'll try to give you some exercise on the defining your generic classes. Okay? Do you got maybe 5 minutes, 7 minutes, maybe? Okay, let's do a little bit recursion, a little bit. Okay. Okay, and then after that we'll we'll get there when we get there. Okay, so now if you go to the end of the lecture over here, so there are, let me just remind you again. If you go to the end of the lecture, there are links for the tutorial videos over here. You can look at them, okay? One is about hash map, the other one is about ArrayList. Let me do recursion very quickly. I'm not being too ambitious, but just do a little bit, okay? Recursion is quite a challenging topic, okay? You will actually have to use recursion for the rest of your degree, for sure. Every course requires some certain amount of recursion, either conceptually or programmatically. I'll try to give you as much introduction as possible with some limited examples. I'll try, okay? But feel free to interrupt me, okay? If you can get about 40% of recursion from my class, I'll be happy. Well, if more, the more the better, of course. Okay, I'm sure you can do better. Okay, number one, how can you do more practice about recursion? So there is a website called Coding Bet. From today, I would suggest, maybe either from today or after Wednesday, go to these two links over here. They got an abundance of exercises for you to define recursive methods. I think at your lab exercises, one of them will be about this kind of style as well. So that's number one, to do some exercises. Okay? Any method you're not too sure how to do, you can look at the solution over there, or just come to my office hour. I will try to lead you to the solution. Okay? And for those of you who are really interested getting recursion 100% mastered, the best way is to learn a new language called functional programming language. It's beyond this course, don't worry. I'm just saying, if you really want to explore more, Haskell is a good language to learn for recursion. If you want to know more, feel free to speak to me. Okay? It's not covering this course. I'm just saying, if you want to, feel free. You're encouraged to. Okay, let's talk about recursion. So what's the principle of recursion? Okay, let's at least talk about the principle quickly. Okay? So now I would say let's talk about principle first, and then we'll talk about code possibly next time. So every recursive problem you're given is going to fall into this kind of pattern. Okay? Let's get a pattern right, and then we can see that for every solution we're going to go over in the class, they're going to follow this. I'll keep emphasizing that to you. Okay? So let's talk about it. How do you solve a problem recursively as opposed to iteratively using a loop? Very different. Okay? So always you will be given a problem. Okay? If the problem is small enough, so when I say small, I should put it in quotes. If that is simply small enough, you can solve it directly. So given a problem, you can simply return a green back to me, just right away, conceptually. Okay? However, it's not the case usually. It will be big enough such that you cannot solve the problem right away. In that case, you have to follow so-called divide and conquer methodology. Divide and conquer. Later on, when you take the 3101, later in the third year, you actually see a lot of divide and conquer. Okay? We'll try to give you some as well. So now here's a general guidance. Okay? When you are given a big problem, okay, so big, such that you just cannot solve it right away. Okay? So here's what you would do. Number one, think about how we can divide the big problem into smaller problems. Okay, you can see this guy here is smaller than the original one. This one is smaller. This one is also smaller. Each problem there should be strictly smaller. Okay, so here strictly is very important. Strictly smaller. And then for every one of them, you simply this part is the most non-intuitive part of recursion. Okay, I'll highlight for you. You simply over here assume the solutions for these smaller problems, for the blue boxes over here, they simply just exist. You don't have to worry about how they will be computed. They just exist. Okay? That's the most unintuitive part. Okay? You assume solutions to the smaller problems simply exist. You got this guy here, you got this guy here, you got this guy here. And then all you got to do later is to say, given that this solution, and this solution all exist, I can simply somehow combine them in a way, somehow. And then I can get my final solution. Okay? Everything is still very abstract at this point, but I want you to keep in mind this particular pattern, the steps. Okay? Every problem that we're going to look at, even the harder problem, if you follow these kind of steps, you can solve it. The second last step is the most difficult one, to really convince yourself. Because when you say, I assume something, but what if my assumption is wrong? I would say you have to make sure your assumption follows certain shape. Okay? That's something we'll talk about. Okay, so how do we do recursion programmatically? What you will see is, I'll just give you one example. Let's say I have a method here called I over here, and then you'll see that somewhere in the body of my method, I call the method itself. That's recursion. Basically, every time you see the method calling itself in the implementation, that means you have recursion. And every time you have recursion, you can think about that kind of pattern over there. Okay? So now, for this particular case, you can see we got J over here. So J, you can think about MJ It's just like a so-called recursive call. Recursive call to the same method. Okay, that's all I want you to know. Okay, are you okay with this? Do you think I have just 1 minute or two? 1 minute? Okay, 1 minute? Okay, deal. I want to talk something very quickly if you don't know about this. Do you know what a Fibonacci number is? Yeah? Yes? No? Yeah, okay. Start with 1, and then 1, and then the next number is going to be the sum of the previous 2, right? Okay, 2, and then 3, and then 5, etc., right? Okay, so now here's my little assignment to you. Don't peek on the slides, okay? Two examples for you. Think about, one is factorial. You know factorial from the math class, I'm pretty sure. If you don't know, speak to me before Wednesday, okay? And then Fibonacci number, okay? The only thing I want you to do before Wednesday is, how can you use a loop to implement? Number 1. And number 2, is it possible to have a recursive definition for these two methods, given what we have said? You can look at the introduction slides on the recursion before you see the code, okay? Think about this, and then we'll start from here from Wednesday. Okay, I'll see you on Wednesday.